Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble codes P0751 and P0752, which are concerned with the shift solenoid valve A in the Honda Accord models manufactured between 2008 and 2012. DTC P0751 indicates that the shift solenoid valve A is stuck in the off position, while P0752 indicates it is stuck in the on position. Both of these issues can have significant effects on the vehicle's transmission performance, preventing it from shifting gears smoothly. When the vehicle experiences these DTCs, it may exhibit rough or unpredictable shifting, or even enter a fail-safe mode where it limits the operation of the transmission. Proper diagnosis is crucial for restoring optimal vehicle performance. Throughout this troubleshooting guide, we will break down the various steps, possible causes, symptoms, and provide a systematic troubleshooting process to identify and rectify the underlying issues related to these DTCs. DTC P0751 and P0752 pertain to the operation of the shift solenoid valve A, an essential component located within the transmission assembly. The shift solenoid valve A is responsible for controlling the flow of transmission fluid, which in turn allows the transmission to shift gears smoothly. A stuck valve can lead to significant performance issues as it directly affects the transmission's ability to change gears appropriately. If the valve is stuck off, the vehicle may not shift into higher gears, while a valve stuck on may cause it to remain in a lower gear, resulting in reduced power and efficiency. Understanding the role and location of this component is vital for diagnosing and addressing the trouble codes effectively. When troubleshooting, always check the condition of the valve to determine if it can be repaired or needs replacement. The possible causes for DTC P0751 and P0752 include several factors that can hinder the proper function of the shift solenoid valve A. First, a faulty shift solenoid valve A itself may be the culprit, either due to wear or internal failure. Low transmission fluid levels can also lead to a lack of necessary hydraulic pressure, which may prevent the solenoid from operating correctly. Additionally, the presence of debris or contamination, such as metal shavings from internal components, can cause blockages and affect solenoid performance. Lastly, issues with the electrical connections, such as damaged wires or poor connections, may disrupt the solenoid's operation. Addressing these causes starts with a thorough investigation of each potential issue to restore proper operation of the transmission. When DTC P0751 or P0752 is present, there are several symptoms that may be observed, each indicating a problem with the shift solenoid valve A. One common symptom is rough shifting. Drivers might experience hard or clunky shifts between gears, reflecting that the solenoid is not adequately controlling fluid flow. Another issue may be the transmission getting stuck in one gear, leading to a lack of acceleration or responsiveness. In severe cases, the vehicle might go into a fail-safe or limp mode due to the faulty solenoid, drastically reducing driving capability. Additionally, warning lights on the dashboard may illuminate, alerting the driver to a transmission problem. Recognizing these symptoms early can prevent further damage and costly repairs. The first step in troubleshooting DTC P0751 and P0752 is to warm up the engine to normal operating temperature, which is identified by the activation of the radiator fan. This ensures that the transmission fluid is at the correct temperature for testing, which is crucial for accurate diagnosis. After warming the engine, it is essential to check that the transmission is filled to the appropriate level, as insufficient fluid can lead to erratic shifting and trigger DTCs. If fluid leaks are present, this may indicate further underlying issues that need addressing before proceeding with the diagnostic steps. By ensuring the engine and transmission are at optimal operating conditions, the remainder of the troubleshooting can yield more reliable results. In the second troubleshooting step, it is necessary to drain the automatic transmission fluid, ATF, through the strainer to check for the presence of metal debris or excessive clutch material. This inspection is crucial, as the presence of such materials can indicate internal transmission wear or damage. Metal debris may suggest that components within the transmission, such as gears or clutches, are deteriorating. On the other hand, excessive clutch material may indicate problems with clutch engagement, requiring further analysis. Depending on the findings, if there is any abnormal material detected, the next step would be to replace the entire transmission to prevent further complications. If none is found, replacing the ATF can help maintain the health of the transmission system. If the inspection of the ATF strainer reveals no metal debris or excessive clutch material, the next step is to replace the ATF. Using the correct type of ATF is essential to maintaining proper transmission operation, as using the wrong fluid can lead to further issues. After replacing the fluid, it sets the stage for a more accurate diagnostic process in subsequent steps. This replacement will refresh the hydraulic properties of the fluid, allowing for optimal performance of the shift solenoid valve A. With the new fluid in place, you can advance to the next troubleshooting step, which involves turning the ignition switch to on or position 2, preferably with the engine still running. For the fourth step, turn the ignition switch to on, also referred to as position 2. This enables the vehicle's onboard diagnostics to operate while ensuring that all associated electrical systems are powered. In this position, it's important to prepare for clearing any stored diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. Confirming that the HDS can communicate effectively with the vehicle's computer is essential for troubleshooting, as it will guide the next steps based on real-time data. With the ignition in the on position, you can proceed to clear the DTCs and reset any systems that may have stored errors previously. This helps establish a clearer baseline for further diagnostics regarding the functionality of the shift solenoid valve A. In this fifth step, use the Honda Diagnostic System, HDS, to clear any previously stored diagnostic trouble codes, DTCs. This process resets the diagnostic information, allowing you to test the vehicle without the interference of historical codes. After clearing the codes, the focus shifts to conducting a test drive to observe the vehicle's performance. Making sure to drive the vehicle with the shift lever in the drive position for at least 11 seconds is crucial, as this allows the transmission to shift through all 5 gears. During this test drive, pay close attention to how the vehicle responds to shifting, noting any irregularities. After the drive, it's essential to check the OBD status again using the HDS to determine if the DTCs return, indicating whether the initial problem persists. Monitoring the onboard diagnostics OBD status using the HDS is critical in the 6th troubleshooting step. After the test drive, check for the presence of DTC P0751 or P0752 in the diagnostics menu. If the HDS indicates a failed status, it signifies that the issues with the shift solenoid valve A are still present, warranting further investigation. Conversely, if the HDS shows passed, it implies that the system is operating normally at this time. However, if it indicates not completed, you would need to rerun the previous test drive steps. Understanding the outcomes of this monitoring step is essential for deciding the next course of action in resolving these diagnostic trouble codes, thereby ensuring the normal functionality of the transmission. For troubleshooting step 7, The DTC must be cleared again using the HDS to re-establish a clear diagnostic baseline. After clearing, navigate to the miscellaneous test menu and select the feature for shift solenoid valve A. At this point, check whether the solenoid operates correctly, which can often be verified by listening for a clicking sound indicating that the valve is functioning. The clicking sound signifies that the solenoid is engaging and disengaging properly, which confirms that the electrical part of the system is operational. If no sound is heard during this test, it usually suggests that the solenoid itself is faulty and would necessitate replacement. Documenting the results of this testing is essential for moving to the next steps in the troubleshooting process. In Step 8 of the troubleshooting process, the key task is to determine whether a clicking sound can be heard when testing the shift solenoid valve A. If the solenoid is functioning correctly, the clicking sound should be audible, indicating that the valve is operating as intended. However, if no sound is heard, this indicates a failure in the solenoid, and it must be replaced before proceeding further. Once the solenoid is replaced, follow up by continuing to Step 12 to retest the transmission system. This step is integral, as it addresses the root of the malfunctioning issue and sets the stage for confirming if the replacement resolves the original DTCs. Conducting follow-up tests after replacement ensures the resolution of the issue and the return of the vehicle to optimal operating conditions. During this 9th step, a test drive needs to be conducted once again with the shift lever in the drive, D position. This time, it is important to observe the transmission's capability to shift through all 5 gears smoothly. Driving for at least 11 seconds allows you to assess how well the transmission responds after the potential replacement of the solenoid valve A. Pay close attention to any signs of hesitation or rough shifting during the driving process, as these can indicate lingering issues that may require additional attention. After the drive, it's vital to check the performance and behavior of the transmission to help confirm whether the previous issue has been successfully resolved. In this 10th troubleshooting step, it is crucial to monitor the OBD status using the HDS once more after the repeat test drive. This helps verify the functionality of the system post-repair. Checking for the presence of the DTCs P0751 or P0752 will reveal whether the previous repairs were effective. If the HDS communicates that the status is failed, it signifies ongoing issues with shift solenoid valve A, which may require further repairs or perhaps the replacement of the transmission itself. Conversely, if it indicates passed, it denotes that the repair was successful and that the transmission is functioning correctly. This ongoing monitoring plays a critical role in ensuring that the vehicle operates as intended and maintains long-term reliability. In the 11th step of the troubleshooting process, it's important to check for any pending or confirmed DTCs using the HDS. This evaluation will indicate whether further issues remain unaddressed in the system. If DTC P0751 or P0752 appears again, it means that the issue persists, and steps similar to those undertaken previously may need to be retraced. However, if there are no DTCs indicated, move on to verify the normal operation of the transmission system. The ability to ensure all stored DTCs have been resolved marks the completion of this diagnostic and troubleshooting process, affirming that the vehicle is ready for safe and effective operation. As you reach the final repair verification, make sure that the Honda Diagnostic System, HDS, indicates a passed status for DTC P0751 and P0752. This confirms that the corrective actions taken have resolved the initial issues relating to shift solenoid valve A. Additionally, it's important to assess for any new or ongoing issues that may have surfaced throughout the diagnostic and repair process. Documenting all repairs, findings, and test results ensures a thorough record-keeping process which is invaluable for future diagnostics. Thorough verification at this stage helps in ensuring sustained vehicle performance and reliability, making sure that previous issues do not reoccur and that the transmission continues to operate optimally. Implementing preventive maintenance for the transmission system can greatly reduce the likelihood of encountering DTCs like P0751 or P0752 in the future. Regular changes to automatic transmission fluid, ATF, is crucial. Ideally done every 30,000 to 60,000 miles, or as specified in the owner's manual, to ensure that the fluid maintains its necessary properties for hydraulic function. Additionally, routinely inspecting transmission components for wear and any signs of debris or leakage can help identify potential issues before they escalate into failures. Monitoring performance metrics, such as shifting smoothness and responsiveness, also plays an important role in spotting problems early. By remaining vigilant with these maintenance tasks, you can significantly extend the life of the transmission and enhance overall vehicle reliability. In conclusion, diagnosing and addressing DTC P0751 and P0752 requires a systematic approach to ensure effective resolution of the issues related to shift solenoid valve A. Throughout the troubleshooting process, identifying all potential causes and symptoms is essential, from fluid conditions to solenoid operation. Performing targeted repairs based on thorough diagnostics will lead to improved transmission performance and enhance vehicle safety. Regular preventive maintenance should also be performed to mitigate future occurrences, creating a proactive strategy for vehicle longevity. By adhering to these recommended practices, you can help ensure that your Honda Accord remains in excellent operating condition, minimizing the risk of transmission-related troubles. Please like and subscribe to the channel. See you next time.